All right, so we have already learned how to measure liquids in a graduated cylinder. Okay, and we said you have to look at the bottom of the meniscus, and we have to estimate the final digit. Remember that? Remember having to estimate the final digit? Yes. All right. Well, what looks is there anything that looks strange to you about this device here? If this is a glass measuring device, we're going to measure liquids in it. What? Upside down. Actually, it's right side up. Okay? But it's designed to do something different than the graduated cylinders we used before. With the graduated cylinders, it was small at the bottom and high at the top. So this is small at the top and high at the bottom. Okay? Let's suppose that we have a liquid volume in here. Okay, that comes through right there. You'll have an edge right there, and then all of this down here is going to be liquid all the way down, you know. That makes sense to you, what I'm doing? Alright? So assuming you get the point of this illustration, there's a meniscus that comes through right here. And if you use that little device I taught you to use, you'll get that little black line right there, and you can kind of see where the edge is, okay? So it'll be easier to see. That little white card with a black line in it, big fat black line in it, okay? So where is the bottom of the meniscus here? What is the measurement here? Anybody? Okay, so let's see. Yeah, somewhere along right here. Okay. Oh, I'm a little bit high. Right there, maybe. Would that be fair to everybody? Looks reasonable to you? Alright. So he says 21, 2, 3, 4.2. Would you agree that's a reasonable measurement? But you can't count from down here. You couldn't say 25.8, could you? Because it goes in this direction. The numbers go higher as you go down, lower as you go up. So 24.2 is a reasonable measurement. Let's say it's in milliliters. Okay? Why in the world would we have a device that's numbered this way? What would we use this for if it's numbered backwards? What would be its purpose? So a model would be trying to figure out why things didn't really work, right? Or they behaved with it. Well, this is not a behavior, but let's think about it. Why would you have something that's numbered enough? What we're normally used to using? Huh? Mary, well, what is the something else we're measuring? Huh? Okay. What? Why would we want the numbers to go higher this way and lower up there? Yeah. The space not filled up with liquid, okay. Two liquids that separate, maybe. How about, yes?
What's the call when you got like irregular object in there and you try to find?
Oh, well, that'd be finding density. That'd be a way to find the volume of an irregular object for the purpose of finding density of an irregularly shaped object. Okay, it's called displacement. I'm not sure how that would help you because with density you want it to rise when you put the object in there. Okay. All right. How about if I wanted to measure how much stuff I take out? I'm not telling. I don't want to know how much is in here. I want to know how much I took out. It makes more sense to have the numbers go in this direction, doesn't it? So if I'm figuring out how much liquid has been taken out, I might use a device like this. And there are a couple of devices typically used or commonly used in a chemistry lab. One's called a burette. Okay. Sometimes it's spelled B-U-R-R-E-T-T-E. I'm not sure why, but anyway. Maybe that's the French spelling. That's the American spelling. I don't know. I'm probably being disrespectful to French speakers. I don't know. I'm not trying to. Okay. Anyway, another is a pipette. Is it 2 P? I can't remember now. I think it's 1 P. P-I-P-E-T-T-E. That does have 2 T's and E on the end, though. So you don't really have to know that. We will work with burettes some, but not pipettes in here. although commonly they're used in a chemistry lab. All right. So let's say we have a question like this. Suppose that this device here originally had 4.6 had a liquid measurement of 4.6 milliliters. Question: how much was taken out? If I originally had 4.6 milliliters, at least the way this is marked on here, how much was taken out? 19.6. How'd you get that? Subtracted. It really isn't that hard. Just subtract. Okay? Take the final measurement minus the initial measurement. And by the way, whether you find a difference in anything in a chemistry or just about any science that I know of is always final minus initial. So the change in some measurement is always going to be final minus initial. Okay? That's just an aside, but that's just why. Just so you know. Okay? So this is the final minus the initial tells you how much was taken out. Got that? All right.